Hello everybody, the subject today is load monitoring in motor-driven systems. If this is something that you really would like some answers for, we've come to the right place. Today we're at Charter Controls. We're now with Mr. Malcolm Greenhill, who's the founder of Charter Controls. Malcolm, we're going to talk about motor-driven systems. What makes them vulnerable and why have they become more important? Why has motor-driven load monitoring become more important in recent times?
Well, a variety of factors really. Customers are using them for a variety of reasons. Operational efficiency, reduction of downtime, obviously very, very important. And working with most of the water authorities in the UK who wants a pumping station to flood their house these days. Right. And we monitor pumps as one of the many tasks we get involved in. So it's very, very important.
And so there are obviously cheaper options that are out there. So why is it that they should go for a proper load monitoring system?
Well, this has always been one of our problems. The water authorities or any other specifying body will tell the control panel manufacturer to have a load monitor in the system, but they won't specify what type of monitor that is, what principle it's using. Control panel builder, obviously to do their task, will probably look at the least expensive option, and some of them will try to use current monitoring, or in the slightly better sense, phase angle monitoring. Now, both of these monitoring principles have issues when it comes to motor load, okay? But when you're faced with a current monitor on the one hand costing £60 and a load monitor on the other hand costing £400, £500, it's clear that the panel builder, the person selecting the product, is going to be heavily swayed towards the lower cost product.
Sure.
But he's not doing himself any favours, because current monitoring and phase angle monitoring will not pick up load disturbances, motor load disturbances in all circumstances, and they're also susceptible to variations in site conditions, such as site voltage. If site voltage dips, the load on the motor goes up. Have you seen a load effect on the machine indicating a fault, or have you just seen a voltage dip?
So Malcolm, that's interesting. So let's focus here on Charter Controls itself. What's the role that Charter Controls plays for its audience in automation in the UK?
Well, we like to solve customers' problems. We've got a range of products that customers might come to us and say, have you got something that'll do this? We have this problem. And that's what we love to do. Problem solving is great fun.
Okay, so you're taking headaches away.
Oh, absolutely. Reducing pain points, whatever you want to say about that. Yes. You know, I can give a number of instances where, particularly with load monitors, motor load monitors, where we've gone to site to solve one problem and the engineer on site has said, that was good. Can you do this?
Right.
And one that comes to mind was Jaguar in Solihull. I remember going up there one day. It was on Easter Sunday because it was the only time they could stop the production line so we could get a look at the issue. And as I walked to the production line, I saw a bucket conveyor on the ground, the long chain of a bucket conveyor on the ground. And I said, oh, what happened there? And they said, well, bucket conveyor, the chain snapped. I said, why did it snap? Did you get a jam? And they said, well, yes. I said, well, you should be using one of our load monitors on that. They did. They were happy. And then they started coming to us with all the other problems they had around the plant.
That's absolutely brilliant. So it's having a wider perspective on the issues that people are facing then.
Absolutely. I often think I should have been a mechanical engineer instead of an electronic engineer because I have a great grasp of mechanical principles and issues, and I'm able to see and understand their problems and bring the solution to them.
That's absolutely brilliant. Your passion for this subject really comes across.
Yeah, load monitoring is a lot of fun, and I mean, one day you're dealing with a machine pumping chocolate in Banbury, or you're in a sewage works solving a problem on a 50-meter scraper bridge that gets pushed by the wind, and when it gets pushed by the wind, it upsets the load monitor.
Right.
So we have special load monitors for that circumstance. You know?
Wow, it's incredible. So Malcolm, I'd like to ask you about the HPL 500 from UniPower. Could you give me some of the benefits of this product?
Well, it's great you ask about the 500. It's the newest product in the series of UniPower motor load monitors. And it incorporates a number of the features from the previous series, the 400 series, but also brings more features to the customer. For instance, it has outputs suitable for feeding load information into SCADA systems for feedback. It has freely programmable output relays so that you can define whether they're an overload output relay or an underload output relay. Okay. It has 2 output relays, that's another feature rather than 1 as the previous HPL 110. And it also has a patented, unique power supply which enables it to operate on single-phase and 3-phase voltages worldwide.
Right.
Apart from the 500, there are a couple of developments of the 500. One's known as the 530, the other known as the 540. 540, I'll go there first, is specifically a conveyor monitor. It will replace, for instance, a small PLC, which is counting the number of overload events. If you imagine a conveyor travelling forward and it jams. That could cause a trip, would cause a trip if you're using a load monitor, but what do you do then? An engineer goes to site, clears the jam. That's a bit expensive, isn't it? How about the load monitor automatically reverses the conveyor, then pauses, and then sends it forward again and just sees if it clears the jam?
Okay.
Well, that's exactly what the 540 does. And it has a counter. You can set up the number of reversal attempts. And if, and only if, it hasn't cleared the jam on the last of the programmed attempts, it will back itself away from the obstruction so that when the engineer does turn up on site, he hasn't got to do that. And then it will raise an external alarm to call the engineer in.
Brilliant.
That's the HPL 540. HPL 530, very, very clever device. Not only does it read true motor load, but it also, or variations in true motor load, it also reads how fast those variations in load are occurring. In other words, an instantaneous jam, as opposed to a slow increase in power, which, say for instance on a conveyor belt, a slow increase in power might indicate you've got enough material on the conveyor. You stop a feed conveyor onto it because there's enough weight on that conveyor. But what happens if literally a spanner drops in the works and jams the works just like that? That's an instantaneous load increase. The HPL 530, by a very clever method, will detect the rate of change of power, delta time, and will trip the motor instantaneously.
So are you, with this product, are you essentially stopping costly downtime?
Oh, without a doubt. Right. Without a doubt. I mean, yes. Yes.
Yeah, absolutely excellent. Brilliant. So, Malcolm, energy efficiency, the dynamic has changed. Yeah. Energy costs are high. How can load monitoring be an aid with energy efficiency and sustainability as well?
Well, the thing that springs immediately to mind is switching something off if it's not needed. If that machine's been running at a nominal power, a low load for X period of time, it's not in use. Switch it off. There might be other applications, such as we've got a customer that is using a screw press to extract oil from seeds. And they measure the amount of load on the motor for a period of time to know that they've extracted the optimum amount of oil from the seeds. Well, they're not having to do that for too long, are they?
Right.
So they're saving the power of the motor driving the press.
Right. No, very good. So energy costs being ever higher, do you think that you potentially could help panel builders, end users, to save energy?
Now that's a difficult question to answer. We'd need to study the application, and certainly where we would spot opportunities to reduce energy usage, we would always do that.
Excellent, yeah, that does make sense. So Malcolm, we've all become a lot more smart in the equipment that we're using. So do you think load monitors play a part in a more connected, data-driven world? Do you see that happening?
Oh, without a doubt. That's why we provided the HPL 500 with the analog output proportional to the load, so that can be fed into a SCADA system and used later for calculating how much it's costing to run a particular machine or process. That's part and parcel of it. And also a small part of the UniPower load monitoring, motor load monitoring range are kilowatt hour meters. Not the sort of thing you'd have in your house, but a much more sophisticated version that will work in an industrial environment.
Absolutely brilliant. So really, as we evolve in this sense, then these products are going to become more used?
Oh, I think yes, as more and more requirement for smart energy monitoring, without a doubt.
Malcolm, I've learnt a lot today from my visit, but finally, I'll put to you one question. If you could leave one message with control panel builders and system integrators about motor-driven protection, what would it be?
Well, I think I'd have to refer you back to your first question, in which I try to explain that control panel builders will sometimes, or many times, select the wrong product for the task. I would urge them to understand their customer's specification, and when their customer says load monitoring, well, current monitoring is not load monitoring, phase angle monitoring is not load monitoring. There is only one purely electrical form of load monitoring, which uses a standard power equation, square root of 3 times current times voltage times cos phi equals kilowatts. It's as plain and simple as that. And if they don't use that, or devices that use that principle, and they go for a cheaper option, it could turn around and bite them in the bum later down the line.
That's fair enough. That's a brilliant analysis, and thank you very much for sharing it with us. So thank you all for watching. Now, obviously, this is a subject that does impact the viewers that we've got to this. So what I would encourage is, why not ask more? There's so much more to dig into on this. Talk to Malcolm and the team at Charter Controls and find out how they can help. And let them explain to you specifically why the product that might be more expensive could be so important. So take the time and check out the website, but please get in contact. Thanks very much for watching. Thank you, Malcolm, so much for your time.
No problem. Look forward to hearing from you.